So to find the length of a line or a distance between 2 points, let's start with an example so we understand where is it coming from. So assume that's our point A and that's our point B, and we want to find the distance between 2 points or the length of A and B. So let's give the point some coordinates. So this one here is -5, this one here it's -3, and let's say this one here is about 3, and this one, the coordinate of that point is 2. Okay, so A is 3, 2, and the points B, it's -3, -5. So to know the length of a line or the distance between those 2 points, let's create a right angle triangle where the line that we want to find the distance for is our hypotenuse. So to know the distance, we can apply Pythagoras. So if we know the length of the horizontal line and square it, plus the length of the vertical line, square it, and then all under square root. So it's just simple Pythagoras. Now, how do we know the length of the vertical, or horizontal line? So the length of the horizontal line is the difference between the two x coordinates. So we're starting at -3, we're ending at 3, so the length is 6. So the length is 6. So basically we're doing -3 minus 3. And then the length of the vertical line, obviously -3 minus 3 is -6, but because it's a length of a line, so we're using it as a +6. And now the vertical line is the same, so it's the difference between the two y-axis. So we're starting at -5, we're ending at 2, so it's obviously 7. Right? So now to find the length of A and B, we're going to do 6 square, applying Pythagoras, plus 7 square, all under square root. So this is basically the understanding behind the distance between 2 points, the rule to come up with the distance between 2 points or the length of a line. How are we going to write that as a rule? So the length of a line, AB, basically, as we said, the difference between the two x's. So x2 minus x1 all square plus the difference between the two y-axis square. So what we did in here, so we've said it's up to you, where do you want to start? So it's -3 minus -3 square plus 2 -5, sorry, because we want to start the same points. We started at -3, so that's our x2. That means this is our y2. -5 minus 2 square, and that gives me -6 all square plus -7 all square, and obviously that gives me 36 plus 49. So as you see, because we're squaring, so it doesn't really matter if we do this -6 or 6, but I've written it here as a +6 because it's a length of a line. Okay, and then you get the answer. And because we're going to put all that under the square root, as we have not found the square root yet, 85. Now the square root of 85, you can just find that in the calculator. 9.22. Thank you. So trying to prove that the distance between the point 18 and -2, -1 are equidistant. Those 2 points are equidistant from -2, 4. Equidistance meaning you're going to deal with the distance formula, and equidistance mean the distance between this point here, and -2, 4 is equal to the distance of between -2, -1 and -2, 4. So we will apply the distance formula twice. So we're going to apply it first between 1, 8 and -2, 4. So D1, I'm going to call it D1, the first distance. The difference, as we said, is the difference between the two x-axes. So 1 minus -2 square plus 8 minus 4 square. Give me square root 3 square plus 4 square. Or 5. So the first distance is 5. Now we're going to find the other distance, -2, -1, and -2, 4. And we're going to call it D2. So -2 minus 2 square plus -1 minus 4 square. And that gives me 0 square plus 5 square under square root, and that gives me, you can do it 5 squared is 25 and then square root of 25, or that square root eliminate that square, so it's the answer is 5. So you have to write D1 equal D2 and it's proven.